Hi everybody, Mr. Schaefer here again. I'm just going to give you some feedback on the logarithms worksheet. I know this was a self-assessed assignment, but it's worth pointing out that a mark scheme is not necessarily equal a model answer, and there are stages which I might expect to see you go through when you're actually showing your working. And also mark schemes are not necessarily that easy to read. They're designed for trained examiners, not for students. So if you've got any questions about the mark scheme, let us know and we'll see if we can sort those out. Okay, I'm now going to share my screen and do a few of these things on the whiteboard. If I can find the right one. So here we are. Okay, so first question, solve the following system of equations. This is pretty classic. Right, so from the first equation, from equation 1, label these equation 1 and equation 2, a bit of labeling, signposting, tell the examiner what you're up to. What you're up to, we can rewrite equation 1 in a non-log form as x plus 1 squared equals y. Similarly, we can do that to equation 2, which is that y plus 1 to the power of a quarter is equal to x. That's from equation 2. And if we manipulate that to make y the subject, raise each side of the equation to the fourth power, we get y plus 1 equals x to the power of 4. So y equals x to the power of 4 minus 1. So we can now get y the subject of both equations, so we can equate those two sides without making an equation in x. At this point, I think I'd be reaching for my calculator, looking to solve these using perhaps using the polynomial solver or solving graphically, and you get solutions which are that x equals -1, which is not actually possible because that would, if x was -1, we'd be taking log to the base 0 up here, so that's not a solution. That's not possible. We have the other solution out of it, which is x is 1.70, 3 significant figures, and y, the corresponding value of y is 7.2. Excuse me, something's gone wrong there. 7.27. Question 2. Key to all these sorts of questions is to get the logarithms in the same base. Doesn't matter, this is a natural log. So I'm going to rewrite the equation as 4 ln2 minus 3 times ln2 squared. 4 is 2 squared. Which allows me to take this power outside the logarithm, giving me 4 ln2 minus 6 ln2 is equal to minus ln k, and I have no idea why I wrote that as a k squared up there. That's totally wrong. Subtraction, minus 2 ln2 equals minus ln k. So ln k is equal to 2 ln2 is equal to ln2 squared ln 4, so k equals 4. Okay, I've done this one step at a time. I think that is ideal, but if you wanted to, you could probably miss the odd step out. I think the examiner would condone that. Question 3, solve the log equation. So, what should we do here? The first thing to do is get all the logs on the same side. So, log to the base 3 of x plus 17. And that's doing this strange thing again. Minus log to the base 3 of 2x. And I put the 2 onto the other side too by adding 2 to each side. So we've now got a log subtraction here, so I can say that this on the left hand side is log to the base 3 of x plus 17 over 2x. Equals 2. Then I'm going to take reverse logs of each side. So I'll do anti-logs x plus 17 over 2x. And what am I going to do here? I'm raising what I'm done, taking 3 to the power of the log. So that's 9. 3 squared. That indicates that is log of 3. 2 is log of 3 squared. So there we go, simple linear equation in x. Subtract x from each side. 17 equals 17x. X equals 1. Question 4. Again, we're just looking at logs, simple log equations. This is an addition, so it's actually effectively the log base 2 of x times x minus 2 is equal to 3. So if I do inverse logs, x times x minus 2 is 2 to the power of 3, which is 8, which gives us a quadratic equation, x squared minus 2x minus 8 equals 0. And that will factor nice and simply to x minus 4, x plus 2 equals 0. And that gives us solutions of x equals 4 and x equals minus 2. But we can rule that one out because the question actually specified that x is greater than 2. So that's not a valid solution. The only solution is x equals 4. Question 5. Find log 2 of 32. You can simply write that down. What power of 2 is 32? And the answer is 5. Part B, slightly more tricky. Log to the base 2 of 32 to the x is equal to log to the base 2 of 2 to the power of 5 to the power of x divided by 2 to the power of 3 to the power of y. That's still all the log of that, which is log to the base 2 of 2 to the 5x over 2 to the 3y. So that simply gives us, that is 5x minus 3y. State your answer though. P is equal to 5x, if is equal to 5, and Q is equal to negative 3. Question 6. P is log A 5, Q is log A of 2. So then we've simply got to write down what log A of 10 is. So that's going to be log A of 10 would be log A of 5 plus log to base A of 2 is equal to P plus Q. B, log to the base A of 8 is log to the base 2 cubed, which is 3 log to the base A of 2 is equal to 3q. And finally, log to the base A of 2.5 is log to the base A of 5 divided by 2, which is log to the base A of 5 minus log to the base A of 2 is P minus Q. Question 7, we're going to deconstruct this and turn it into, this is, we can split this up into two addition, an addition and a subtraction. So log of x squared is 2 log x plus the power of the square root is a half, so that's a half log y, and then because I'm dividing, that would be negative 3 log z, or z if you prefer. Therefore, the answer is 2a plus half b minus 3c. So you have to be able to work either way. Sometimes you're having to put terms together to bring them into a single log. Sometimes you're deconstructing it to make it into a chain of additions and subtractions. And question 8. Paper out. We're going to put this all in terms of nines. So 81 is 9 squared. So this is 2 log to the base 9 of 9. And this is minus 1 log to the base 9 of 9, because that's 1 to the power of negative 1. And this is a half log to the base 9 of 9, because 3 is the square root of 9. And this simply equals log to the base 9 of x. So we can bring these together, and what we end up with is 2 minus 1 plus another plus a half, 3 over 2 log to the base 9 of 9 is equal to log to the base 9 of x. What is log to the base 9 of 9? It's 1, so 3 over 2 equals log to the base 9 of x. So x is equal to 9 to the power of 3 over 2. Square root of 9 is 3. 3 cubed is 27. I just realised as I was doing it, there's probably an easier way to do that, which is actually not to put everything in terms of nines. We could actually have done it alternatively as that is, but by bringing those three things together, log to the base 9 of 81 times 1 over 9 times 3, which is equal to log to the base 9 of x. So you get straight then to log to the base 9 of x is equal to 27. X equals 27. Probably a little less work. So my instinct there to put everything in terms of log 9 turns out to be slightly longer than the alternative. Okay, I hope that's made anything clear. If you've got any questions, please do get in touch via email. Thank you.